A black hole is a region in space where gravity is so strong that nothing, not even light, can escape its gravitational pull. Black holes are formed when massive stars run out of fuel and collapse under their own weight, becoming infinitely dense points in space known as singularities. The boundary around a black hole where nothing can escape its gravitational pull is called the event horizon. The concept of black holes was first proposed in the early 20th century by physicist Karl Schwarzschild, and since then, scientists have discovered many examples of black holes in the universe. Despite being invisible, black holes can be detected through their effects on nearby matter, such as the emission of high-energy radiation or the motion of stars and gas around them. Black holes come in different sizes, from small ones that are just a few times the mass of the Sun to supermassive ones that are millions or even billions of times the mass of the Sun. The exact number of black holes in the universe is unknown, as black holes are often difficult to detect and observe directly. However, astronomers have been able to detect and study many black holes through their effects on nearby matter, such as the emission of high-energy radiation or the motion of stars and gas around them. Based on current estimates, there could be millions or even billions of black holes in the Milky Way galaxy alone. In addition, there are many other galaxies in the universe, each with their own populations of black holes. Some galaxies, such as those with active galactic nuclei, are thought to harbor supermassive black holes at their centers, which can have masses equivalent to billions of suns. Overall, the exact number of black holes in the universe is difficult to determine, but it is believed to be a significant fraction of the total mass of the universe. The current record for the largest black hole that we have observed to date belongs to a supermassive black hole at the center of the galaxy Holmberg 15A, also known as M87, which is located about 55 million light-years away from Earth. This supermassive black hole, known as M87, has a mass equivalent to about 6.5 billion times that of the Sun, making it one of the most massive black holes known in the universe. In 2019, the Event Horizon Telescope collaboration released the first-ever image of a black hole, which was of the black hole at the center of the galaxy M87. The image showed the black hole's event horizon, which is the boundary around a black hole from which nothing can escape its gravitational pull. However, it's important to note that there may be even larger black holes in the universe that we have not yet detected or observed. As technology and observational techniques continue to advance, astronomers may be able to discover and study even more massive black holes in the future. There is no evidence to suggest that black holes have multiple dimensions beyond the 3 dimensions of space and 1 dimension of time that make up the fabric of our universe. Black holes, like all objects in the universe, are subject to the laws of physics that govern our 4-dimensional universe. However, some theories in physics, such as string theory, propose the existence of extra dimensions beyond the 4 dimensions that we are familiar with. These theories suggest that the universe may have additional hidden dimensions that are too small for us to observe directly. While these extra dimensions have not been directly observed, they may have implications for our understanding of black holes and other phenomena in the universe. Nonetheless, the existence of extra dimensions beyond the 4 dimensions of spacetime is still a subject of ongoing research and debate in the scientific community. The amount of matter a black hole can consume during its lifetime depends on several factors, including the mass of the black hole itself and the availability of matter in its vicinity. In general, a black hole's rate of accretion, the process by which it consumes matter, depends on the properties of the surrounding material, such as its density, temperature, and velocity. A black hole can consume matter from a nearby star or from an accretion disk, which is a rotating disk of gas and dust that forms around the black hole. As for the amount of matter a black hole can consume in its lifetime, it is difficult to estimate precisely. However, based on current understanding, a black hole with a mass of 1 million times that of the Sun, known as a supermassive black hole, could consume the equivalent of 1 solar mass of matter every 10,000 years or so. This means that it could consume tens of thousands of solar masses over the course of its lifetime. However, it's important to note that the rate of accretion can vary widely and is difficult to predict accurately, so these estimates should be taken as rough approximations. Black holes themselves do not have a color, as they do not emit or reflect any visible light. The name black hole refers to the fact that the intense gravitational pull of the object is so strong that even light cannot escape from it. Therefore, black holes appear black or dark to us, and are invisible unless they are surrounded by matter that emits radiation, such as an accretion disk. However, when matter falls into a black hole, it can become extremely hot and emit intense radiation in various forms, including X-rays and gamma rays. This radiation can be observed by telescopes and detectors and can provide information about the properties and behavior of the black hole. Additionally, some computer simulations and artistic depictions of black holes may use colors to represent certain properties or characteristics of the object, but these are not inherent to the black hole itself. Black holes are not thought to contain oxygen or any other element in the form of atoms or molecules. Black holes are extremely dense objects formed from the gravitational collapse of massive stars or from the mergers of other black holes. At the center of a black hole lies a singularity, which is a point of infinite density and zero volume. This means that all matter that falls into a black hole, including any atoms or molecules, is crushed and compressed into a single point of infinite density. Furthermore, the intense gravitational forces near a black hole prevent the escape of any gas or matter, so there is no oxygen or other gases in the vicinity of a black hole that could be breathed by any hypothetical life form. Therefore, black holes are not considered to be environments that can support life as we know it. Based on our current understanding of black holes and the conditions around them, it is highly unlikely that black holes contain any form of life as we know it. Black holes are extremely dense objects formed from the gravitational collapse of massive stars or from the mergers of other black holes. At the center of a black hole lies a singularity, which is a point of infinite density and zero volume. This means that all matter that falls into a black hole, including any organic matter, is crushed and compressed into a single point of infinite density. Furthermore, the intense gravitational forces near a black hole prevent the escape of any gas or matter, so there is no oxygen or other gases in the vicinity of a black hole that could be breathed by any hypothetical life form. While some theoretical models have proposed the existence of exotic forms of life that could survive in the extreme conditions near black holes, there is currently no observational evidence to support these ideas, and they remain highly speculative. Therefore, it is safe to say that black holes are not considered to be environments that can support life as we know it. No, it is not possible to see a black hole with the human eye, even if it were nearby. As the name suggests, a black hole does not emit or reflect any light, so it appears black or dark to us. Even if we were very close to a black hole, we would not be able to see it directly. Instead, we would only be able to observe the effects of its gravitational pull on nearby matter, such as the motion of stars or gas. To observe black holes, astronomers use specialized telescopes and detectors that can detect various forms of radiation emitted by matter as it falls into the black hole, such as X-rays or gamma rays. The recent image of the black hole in the galaxy M87, released by the Event Horizon Telescope collaboration in 2019, was not a direct visual observation of the black hole itself, but rather a visualization of the shadow cast by the black hole's event horizon, which was created by the interaction of the black hole's intense gravity with surrounding matter.